Science Integrity Alliance, in partnership with the Collaborative Library, mirror video summaries featuring "Science improves when data is shared, but not all journals are on board yet." Research plays an important role in our lives, whether we realize it or not, because everyone benefits from science. This is why scientific research should be available to everyone. Unfortunately, this isn't always the case due to fees called article processing charges, or APCs, where scientists must pay thousands of dollars to scientific journals to make their research open access or available to the wider public. APCs are a problem because researchers may favor certain journals more than others due to varying prices, while some researchers may not be able to afford to make their work accessible at all. Open access, however, is only part of the story. Researchers should also be able to share raw data, explain their research methods, and provide transparency about their peer review process. Sharing raw data and other materials helps to save time and money by inspiring new ideas, avoiding research redundancy, and encouraging transparency among science and non-science communities. Researchers have studied what happens after authors publish their work in fields like dentistry, emergency medicine, and biomedicine. However, raw data was rarely published along with their articles for several reasons, like strict data sharing policies in different countries or authors simply not having a good reason to share them. To really benefit from what research has to offer, the best option for data sharing is using repositories. Think of repositories as a giant online library that collects research projects and raw data. It's a place where researchers and universities can share their work so others can learn from it and use it. There are different kinds of repositories, like archives and enclaves. Archives are a special type of record where important documents are stored, and enclaves are like top-secret records that require approval for users to access. So since data sharing is clearly important, is it being prioritized in scientific journals? And if so, how are researchers storing these materials in repositories? What types of files are they using? And which journals are more likely to allow sharing in the first place? To answer this question, the lead authors and their team looked at 165 journals in the Medicine, Internal, and General category in something called the JCR. The Science Citation Index edition of the Journal Citation Reports helps researchers understand which journals have the most impact on scientific research by providing different quality rankings. While the Medicine category pertains to medical topics like chronic diseases and family medicine. The team researched different data sharing policies in various journals, if authors could upload their work in repositories, reuse data for new study ideas, or simply share their work openly on different websites, like personal research profiles. First off, they reviewed the instructions that were given to authors so they could understand their policies on open access and data sharing. They recorded the journal names, publisher names, journal websites, and whether the journal allowed data to be uploaded into repositories that organize content based on institutions or based on various subjects. Tarazona Alvarez and colleagues looked at different guidelines provided to authors when uploading manuscripts, written versions of articles, and other materials like raw data, figures, or results. And these were categorized with allowed, and not specified. They also checked to see if the extra materials could be reused or published on different websites, like researchers sharing their work on personal research profiles. Next, the researchers searched PubMed Central, PMC, which is a large digital library that stores research articles on medicine and life sciences. While there were 165 articles they were looking through, 146 of those same articles were also published on the PMC. And they wanted to see how many journals on the PMC allowed supplementary materials to be uploaded. And lastly, they wanted to see what types of formats were being used, like PDFs, spreadsheets, images, or text files to see how the data was being shared. What did the researchers find? Well, they separated their results based on each of the steps in their study design. For the 165 journals, 36.4% allowed authors to upload data into repositories, while 62.4% did not specify any policies. The journals that did accept additional content were journals considered higher impact, which are more influential. The journals that had a lower impact also had a lower acceptance rate of extra materials. Only 2 journals clearly stated that storing materials was not allowed. For the reuse policies, 40.6% of journals allowed article content to be reused, where 29.1% did not allow it, and about 30% did not specify. Journals that allowed reuse had higher impact, whereas journals that were lower impact either did not allow reuse or did not specify. When it came to publishing papers on other websites, such as personal research pages, 47.3% of journals allowed this to happen, whereas 52.7% did not specify at all. Regarding supplemental materials, like raw data, figures, or results, 53.3% of journals accepted this and 46% did not specify. In the PMC, out of 146 journals, only 9.5% of these articles had uploaded data and extra materials in the journals JAMA Network Open, New England Journal of Medicine, Lancet, and more. JAMA Network Open had the highest rate, with 72.8% of its articles including supplementary materials. Lastly, researchers found that the most common file types were PDF files, 48.7%, text, 23.3%, images, 8.1%, HTML files, 7.9%, and spreadsheets, 6%. Now, the study has some limitations to consider. Researchers solely examined journals in the JCR. This means that other quality journals and other databases, which could have had more flexible sharing policies, were not considered. Also, the difference between printed online journals and online journals was not compared, as this could influence data sharing policies. And lastly, the researchers focused on journal policies and not on whether other researchers actually reuse or share their data. Sharing data is becoming increasingly important. During global health crises like the COVID-19 pandemic, open data made it possible for scientists to act quickly and allowed labs across the globe to develop diagnostic tests. While there are debates about how much sensitive data should be shared, most experts agree that open data helps improve the quality, reproducibility, and progress of medical science. However, despite all this progress, there seems to be inconsistent and unclear policies among scientific journals. The authors recommend that researchers should be trained in data sharing, as well as encouraged to share responsibly and transparently, and that safeguards should be put into place to protect private information. This content was created for Mirror, a resource from the Science Integrity Alliance. For more meta-science insights, visit the Mirror Hub at the Science Integrity Alliance or explore video summaries and other topics at the Collaborative Library website.